Awesome. So hi, my name is Emily Muller. I am also a fellow, and thank you for coming today. So my project is titled The Edge in the Environment. Can edge computing contribute to sustainability efforts? All right, so the immediate answer to my question is there are limited sustainability-focused applications which can benefit from edge computing. And so I'll spend the next 15 minutes sort of walking through my findings and how I landed there and some examples where it could potentially be interesting that could develop in the future. So to start off, my questions were, can the edge help sustainability? And how should companies and innovators think about the role of the edge in terms of meeting their climate goals? So as I started off with, there are limited applications. As for the vast majority of ways in which you could think about maybe it would help today, traditional architecture is more than enough. However, of course, the usual technology caveat, as technology evolves, you never know what may come down the pipeline in the future. I bucketed my answers into two categories, hardware and software. Hardware is much more, that was more of a literature review that already exists. In software, I came up with a framework with two different variables from talking to different people. So to walk through the findings quickly, and I'll dive into all of this in a second. In terms of hardware, so you think about actual architecture, edge can help reduce the load on centralized energy-intensive data centers, which can lead to lower computing emissions and costs. Impact is demonstrable, but somewhat minimal. Software is a little more interesting. Came up with a framework that looks at uses of high environmental impact, so looking at applications that have high emissions today, and cross that with highly adaptable, so things that respond really quickly to stimuli versus trade-off between 1 to 2 seconds doesn't really matter. And those are the two most important things to think about. Otherwise, edge provides little to no advantage from a sustainability perspective. So to start off with a little background so that all makes a little more sense, digital infrastructure is the backbone of connectivity, innovation, and flexibility in today's connected world. I'm thinking about it as effectively the backbone architecture where all data runs across. So that falls into two main categories: data centers, which we're all pretty familiar with. These are gigantic centers that are just filled with servers that store and process and compute information. And so if you look at the graph on the right, traditional data centers are the cylinders in the middle. And what the edge does is it creates the cylinders in blue. So it takes that computing power and just pushes it closer to the edge. And that leads to lower latency, which means faster speeds, improved security because you don't have to travel across so much distance, scalability, and cost efficiency eventually. So really, it's not overly different. You're just moving it closer, so you get things a little bit more quickly and a little bit more efficiently. So what does that mean in terms of why does digital infrastructure need to think about sustainability? The chart on the left is global data demand in zettabytes, which are massive. So this is pretty wild that it grew from 33 to 181 over the course of 7 years. This is driven by digitization, IoT adoption, other data-heavy tech trends. To meet this demand, new data centers come online, which increase power consumption, which is the metric you use to think about capacity of data centers. So much so that a couple sources cited that by 2025, 20% of all electricity will be used by the communications industry, which I thought was pretty wild. And this is a major component of that. They use water, they use power to operate. And so why does edge help this? It offers an opportunity to reduce network traffic coming in and out of these gigantic data centers. So by pushing some of that compute to the edge, you're omitting the need to travel over longer distances. That reduces energy, that reduces carbon emissions, and optimizes your use of data processing. It's also a bit newer. It's frankly not new. It's like 10 years old, but it's newer. So it's a bit more efficient compared to the traditional stuff that's been around for much longer. Many of the cloud providers already do this. AW Greengrass is just one example. It's an open source IoT edge runtime and cloud service, which basically just means you can subscribe to it and then run all your stuff on its edge. With the goal to, of course, provide edge, but it does reduce emissions. It's kind of produced and published findings on this. Other cloud providers, Microsoft, Cisco, Google, et cetera, all do this. And so the big takeaway from hardware is there's not much companies can do. It's really on the cloud providers. And they're kind of already doing it. So it's interesting, you can upgrade your subscription to use Edge, but it helps, but not a ton. And I think another interesting caveat here is a lot of the data demand is driven by the hyperscalers. So you've got Google, Amazon, Microsoft, Meta, Amazon, forgetting an A. And they have their own data centers, and they're working on sourcing clean energy themselves. So there's kind of a lot going on here, and not a ton of value to add from additional edge computing. Software gets a little more interesting. So when you think about a framework for how the potential for change, for how edge could impact the potential for change, you want to assess adaptability and environmental impact. So if you think about adaptability on the top, that's the amount of immediate response required for a given use case, or like how twitchy is an application. So something that's really highly adaptable, the trade-off between 1 second and 1 millisecond has massive consequences. So think about an autonomous vehicle. If something comes up, the car needs to react instantly, and if it delays at all, massive consequences. So that's something that's really highly adaptable. Something that's much lower in adaptability is something where that immediate reaction isn't necessary. If you think about a traditional manufacturing line, if something doesn't happen instantly, that's okay. If it takes 2 seconds and can run to its data center and back, that's okay. So that's the adaptability component. And then you think about environmental impact. This is pretty straightforward, but the degree of change a use case can have on emissions, something that has high environmental impact results in net zero, net negative, anything like that. And something that's low, I stopped it at things that minimally improved efficiency. So like LED lighting, I didn't venture into like dirty technologies, if you will. I kind of stopped at, it makes it better, but not really. So when you think about these graphed in a 2x2, on the left-hand side, you have environmental impact, low at the bottom, high at the top. On the bottom, you have adaptability, low on the left, high on the right. And the most important quadrant is the one that's highlighted in orange. High adaptability, high impact. The others are interesting, but don't need edge. They do good things. So for example, LED lighting has an impact. You don't need to connect to anything. If you move to quadrant 2, you have really interesting technologies that have interesting impacts, but they really don't need that adaptability component, like carbon tracking, circular products and services. Again, back to that like really quick trade-off, it doesn't matter, so it doesn't need edge. When you think about things with high adaptability and low impact, things like autonomous vehicles, these are cool, these use the edge. The impact on the environment, we can argue about, but I put it in low because that's something they're still working through. So where I think the really interesting stuff falls is in real-time data tracking and analysis, things like waste reduction, things like traffic management. There's some interesting studies where you can better regulate stoplights. That's, again, really, you need to have that trade-off, needs to be really, really quick. And over time, when cars move more efficiently, you do actually have a pretty significant impact on emissions. So things like that can really help optimize current processes that need to happen really fast is really the only place where this could actually help, and it's frankly already being done. Here are 2 quick examples. On the left is Schneider Electric. They have an EcoStruxure platform. It's designed to help with IoT things, and it monitors and optimizes energy consumption on a manufacturing floor. So it tweaks HVAC and lighting depending on who's in the room, what's the time of day, what's going on to fully optimize energy consumption. So again, using an existing process, making it a little bit better. Very similar on the IBM Watson side. It's optimizing energy consumption and tweaking things to reduce waste. So to bring it all back around, hopefully this makes a little more sense the second time around, there are limited sustainability-focused applications which can benefit from edge computing. But as the edge becomes more prevalent, we'll see what happens. Hardware is really already being done. There's some interesting stuff in software, but again, that adaptability component's really critical to even think about if the edge could be used or not. Thank you. Any questions? Yes?
Thank you so much for this. What about your background?
Yeah, great question. Got a little technical pretty quickly. Didn't mean to do that. I am not an engineer. So I am going to work at American Tower, which just got into mobile edge. And I initially really wanted to do a project in sustainability and sort of did a little Googling and tried to merge the two. I think that's why I landed on a no, because I tried to create my own story. But it was really interesting, learned a lot, and tried to fuse what I was interested in and what could benefit me professionally. Yeah. Yeah.
So curious to understand how, I think the problem is about general emissions from compute processing. That's so edge computing is sort of a solution. Could you talk a little bit more about how much is the tech world really worried about compute being a big contribution to sort of emissions, and is that really a big enough problem for them to look at today, especially with sort of maybe AI usage across the board going high, which needs a lot of compute too, or would AI solution is sort of something that needs edge computing and not edge computing given the massive use of that? Basically two questions. One, a little bit on how big the problem is in terms of emissions and how seriously people taking insight with the use of AI and the explosion of how many people are using it at a B2C level. You see that compute also sort of affecting sustainability.
Good question. So the first one, I think it's definitely, at least I came from TMT Consulting, and in general, data centers are not environmentally friendly at all. They use a ton of water and a ton of energy to keep it cool because they're just these gigantic warehouses loaded with servers. They can't get too hot. And they're all over. They have a ton in Arizona. They have a ton of like really hot places. So they have to keep these like gigantic boxes cold. And so I know a lot of the big tech companies have been working on this for a long time, frankly. I haven't checked up on this, but Amazon at one point said by 2024 they wanted to be completely net zero. I don't know how they're doing on that. So it's something that's definitely in the forefront because you are just running massive servers, and as all of this stuff like generative AI definitely uses more. So will that forecast change? Probably. Just like the more that runs through the internet effectively, the more is going to put demand on things like this. Yes, technologies will get more efficient, and maybe that's the next big thing. I'm not sure. But I would imagine this isn't going to stop anytime soon unless someone comes up with something totally new. They can do the same thing. That would be my guess.
So when you're saying like zero, by sort of saying what that is it more from like proactively or more like buying credits and sort of being net neutral based on their investments in projects to sort of, is it?
It's a great question. I'm not sure. I know a lot of those credits, but it could totally be a combination of everything. Yeah.
So following up on that question a little bit, one reason that cloud providers, or like I've seen cloud providers advertise that they're more sustainable than the alternative of like maintaining your own data center in-house. So just kind of on the spectrum from like these big clouds, data centers to edge computing to actually maintaining your own data center in-house, which do you see as the most sustainable, and did you look at any like in-house systems as well as the other options?
By in-house, do you mean like on-prem?
Yeah.
Gotcha. That I don't know. Based on the logic that which edge makes it better, I would guess on-prem is the best, but that is very much a guess just because of transport, running it through those things and back. Are you using just as much energy in your own building? Maybe. So that's a good question. I'm not really sure what the answer is, but could be interesting.